Hey, welcome to The Explainer. Today, we're going to crack open one of the most important ideas in all of software, object-oriented programming. Yeah, just let that sink in for a second. What if, when you're writing code, you could treat everything like a little Lego block, something you can design once and then copy and reuse wherever you want?
Well, that right there is the magic behind object-oriented programming, or as everyone calls it, OOP.
Okay, so what is it really? At its heart, OOP is all about trying to make our code a little bit more like the real world. It's about bringing some of that real-world structure into our programs. It's really a different way of thinking. So instead of writing these long, complex lists of instructions, you start to think in objects. An object could be anything: a user, a shopping cart, or, yeah, even a car. And every single object you can break down into two really simple parts. First, you've got its properties. These are the things the object has. So for a car, that's its color, maybe its current speed. And then you've got its methods. These are the things the object can do, like driving or braking. OOP is all about bundling that data and those actions together into one neat, tidy package.
Okay, this all sounds kind of interesting, I guess, but you might be wondering, why do we even bother with this? What's the real advantage when you're trying to build something huge, like a big piece of software?
Well, the benefits are just massive. For starters, your code becomes so much more organized. And then there's the big one: reusability. You can design that car object one time, and then you can create 1,000 of them or 1,000,000 without rewriting the code. All of this means your projects can grow and scale up without turning into a complete mess. So how does OOP actually pull all of this off? Well, it's all built on 4 really powerful ideas. People often call them the 4 pillars. Think of them as the secret ingredients that give OOP all its power. First up, we've got encapsulation. The easiest way to think about this is like a capsule or a protective bubble. All of an object's important stuff, its data and its methods, are bundled up securely inside, which keeps them safe from other parts of the code messing with them by accident. It makes your code way more reliable. Next is abstraction. This is all about hiding the messy details. I mean, think about it. When you drive a car, you just use the steering wheel and the pedals, right? You don't need to know how the axle and the engine work. Abstraction is exactly that for code. It hides all the complexity and only shows you the simple controls you actually need to use. Pillar number 3 is inheritance, and this one is a huge time saver. It lets you create a new kind of object that just inherits everything from an object you've already built. So, back to our game idea. You could make a basic enemy object. Then, you could create a boss that inherits everything the enemy has, but you just add a little more health and a special attack. No need to start from scratch. And finally, there's polymorphism. It's a fancy word, but it just means many forms. It's this awesome idea that a single action, like attack, can do different things depending on the object. So for a warrior, attack might mean swinging a sword. For a mage, that same attack command could launch a fireball. Same command, totally different results. It's incredibly flexible. Okay, that's a lot of theory, I know, but let's actually see it in action. A quick code example should help make all of this make a lot more sense. So we're going to build what's called a class. The best way to think of a class is as a blueprint. It's not the thing itself, it's the recipe for making the thing. In this case, a blueprint for making dogs. All right, so here's our dog blueprint. Don't worry if you don't read code. That underscore init part, that's just the set of instructions that runs whenever we create a new dog. It basically says, hey, every single dog we make must have a name. And then we give it an action, a method called bark. So now any dog we create from this blueprint will have a name and will know how to bark. And boom, here's the payoff. This is that reusability we talked about. We use our dog blueprint to create our first object, a dog named Buddy. Then we use the exact same blueprint, no new code, to create a totally separate dog named Max. They're built from the same pattern, but they're 2 unique dogs that exist on their own. So, this isn't just some abstract thing for programmers. OOP is the engine that runs so much of the digital world that you use every single day. Seriously, it's everywhere. In video games, every character, every sword, every health potion, they're all objects. The apps on your phone, every button you tap, every form you fill out, yep, those are objects. Websites, a user account is an object. A blog post is an object. A comment is an object. It's the fundamental way modern software is built. So, if there is one big idea to walk away with, it's this. OOP isn't just a style of coding, it's a way of thinking. It's a mental model for taming complexity by seeing the world as a collection of these neat, interactive, reusable objects. And that brings us to a final question for you. Now that you know about encapsulation, abstraction, inheritance, and polymorphism, which one of those ideas is going to change how you see the apps and games you use every day? Thanks for joining us on The Explainer.